Welcome to EGBTech channel. Myself Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I am discussing about the Millimans Theorem. This is very important theorem in university examinations. There is compulsory problem on this theorem. First of all, what is the statement of Millimans Theorem? That is, in the given circuit, if there are number of sources along with internal resistances, all are connected in parallel, then that circuit can be transformed into an equivalent circuit with a single source along with series resistance. That voltage source called as Vm, Millman's voltage, and resistance is called as Rm, that is Millman's resistance. In the given circuit, if we have a number of sources, that is V1, V2, and V3, here all voltage sources are connected in series with resistances. That means the positive terminal is connected with the element, all voltage sources. Then the formula for Millman's voltage Vm is V1 G1 plus V2 G2 plus and so on by G1 plus G2 plus and so on, where G is the conductance. The formula is 1 by R. That is G1 equal to 1 by R, G2 equal to 1 by R2, and so on, Gn equal to 1 by Rn. Like that, you can find out the product from V1 G1 plus V2 G2. In the given problem, if any source is reverse direction, that is negative terminal is connected to the element, then that corresponding voltage source value we are taken as negative. Suppose in the given problem, the negative V2 is connected with element, then here the corresponding V2 value taken as negative instead of positive. That only changes, then find out the Millman's voltage. Similarly, to find out Millman resistance Rm, 1 by G, nothing but 1 by G1 plus G2 plus and so on. Then that equivalent circuit is called the Milliman's equivalent circuit. After drawing circuit, then across the elements, the deleted element will be joined with Milliman circuit across the circuit. Hence, the circuit forms a closed loop. Single loop circuit can be formed. Then find out the current passing through the element resistance R by I equal to V by R, where V is the Vm and R is the Rm plus R. Rm and R both are in series connection. Then total resistance is Rm plus R. Then I equal to Vm by Rm plus R. Like that, you can find out the current passing through the unknown resistance value R value. Suppose in the problem is given, for example, AC circuit. For AC circuit, all elements are in the form of impedances. Then the reverse of impedance, that is 1 by Z, is nothing but impedance Y. That's why the Milliman's voltage and Milliman's impedance you can find out in the form of impedances Y. That is Vm equal to V1 Y1 plus V2 Y2 plus and so on by Y1 plus Y2 plus and so on. And Milliman's impedance Zm equal to 1 by impedance Ym. That is 1 by Y1 plus Y2 plus and so on Yn. Like that, you can find out Millman's voltage and Millman's impedance in case of AC circuits by using the formulas. You must remember the voltage formula and resistance formula in case of Millman's theorem. This is very easy and simple theorem. There must be problem in university examinations. Then, for example, you can verify the Milliman's theorem by taking the circuit here, the example circuit, that is, find out current passing through 10 ohms. That is, across 10 ohms, you have to find out the current passing using Milliman's theorem. That's why, first of all, you can eliminate the corresponding resistance 10 ohms. Then only we have V1 5 volts and R1 2. Here, observe here, the V2 source, 10 voltage source, negative is joined with the element 4. Then we can find out, the first step is find out Millman's voltage. To find Millman's voltage Vm, Then what is the formula here? We know how many sources in the problem. We have three sources. That's why V1 G1 plus V2 G2 plus V3 G3 by G1 plus G2 plus G3. Then what is the value of V1? That is 5 into G1 value is 1 by 2. Similarly, V2 is reverse direction. That's why taken as minus. Then V2 is 10 and G2 is 1 by 4 into 1 by 4 plus, and V3 is 15 into 1 by G3, that is 1 by 6 by 1 by 2 plus 1 by 4, that is G1 1 by 2, G2 1 by 6 1 by 4 and G3 1 by 6. Then you can simplify that value, then you will get that VM value is 2.73 volts. Then in the same format you can find out by using RM value also, that is Millman's resistance. What is the formula for Millman's resistance, that is RM? The second step is to find out Milliman's resistance Rm. The formula is 1 by G, that is 1 by total conductance values. We have three values here, 1 by G1 plus 1 by G2 plus 1 by G3, that is 1 by 1 by 2 plus 1 by 4 plus 1 by 6. Then that Rm value is 1.09 ohms. That here Millman's voltage and Milliman resistance are to be calculated. Then find out Milliman circuit here. What is Milliman circuit? Milliman's voltage in series with Milliman's resistance. Then across the circuit, you will rejoin the deleted element 10 ohms. So this is Rm and this is Vm. Therefore, what is our aim here? To find out current passing through 10 ohms. That is taken as I10. That is therefore I10 equal to V by R. What is the V value? That is Vm. That Vm value is 2.73 by Rm plus 10. Rm value is 1.09 plus 10. Then you can simplify the equation. You will get the current value, current passing through 10 volts, 10 amperes is nothing but 10 ohms is nothing but 0.25 amperes. Okay, in this way, you can find out first calculate Milliman's voltage, then next calculate Milliman resistance, then draw the Milliman circuit, then find out the required value passing through the element value. Okay, this is the verification of Milliman's theorem. Here, the important point is to remember the formula for Vm as well as the formula for Rm. Both formulas are very, very important. This problem also very most important in gate examinations also. Then practice more. For example, we can take exam problem on Milliman's theorem in case of AC circuit. I'm taking one example AC circuit, that is we have two sources 10 and 20, both are joined with impedances. Then across 40, what is our aim here? To find out current passing through 40 ohms by applying Millimans theorem. Okay, then what is first step for Millimans theorem? You have to find out Millimans voltage here. For Millimans voltage, in the given problem, we have two sources, that is V1 and V2. What is formula here? The reverse of impedance is Y, that is admittance. That's why V1 Y1 plus V2 Y2 by admittance value is Y1 plus Y2. Okay, in this problem, we know what is the value of V1 here, that is 10. What is the Y1 value? 1 by Z value, that is 30 minus J 20 plus V2 value is 20 into 1 by Y2, that is Z2 value 10 plus J 20. by, that is 1 by y1 value and 1 by y2 value. That is y1 is 1 by z1. Z1 is 30 minus j20 plus, and z2 is 10 plus j20. The reverse of z2. Then simplify that calculations. Then Vm value you will get is 18.2 at an angle minus 15.95 degrees volts. Okay, this is the value of Vm. Similarly, you can find out Zm value, that is Millman's impedance. Why? Because this is the AC circuit. The formula is 1 by 2 values are given. That's why 1 by y1 plus y2. Then we know y1 value and y2 value. You can simplify that values. Then you will get Zm value is 20.15 at an angle 29.74 degrees. That is ohms. Okay, in this way, you will calculate Millman's voltage and Millman's impedance. After calculating both values, what is the next step here? That is, you can draw Millman circuit. What is Millman circuit here? This is AC circuit, then AC source here. Then in series with impedance, then that value, that circuit will be connected across that element which is deleted. That is, the previous value is, that is 40 ohms. Then Z value, this is Zm value, and this is Vm value. What is our aim here? To find out current passing through 40 ohms. Then simply, what is formula here? Current is, suppose it is taken as I40. Current passing through 40 ohms is I40. Then I equal to V by R. That is Vm by Zm plus 4. Then you can replace the values of Vm and Zm. Then the current passing through 40 ohms, you will get here 0.31 at an angle minus 25.81 here. That is decrease. Okay, in this way, you can find out the required value across the element here. Okay, remember, in AC circuit, every value you must calculate in two forms. One is rectangular form. That form will be converted into polar form also. Okay, in university examinations, you can represent the values in both forms, rectangular as well as polar. Please subscribe our channel and share to your friends.